Think of an HBA as a network interface card, just a NIC that's specialized for fiber channel networks. For example, if you quickly look at one, like the one on our slide, if you weren't paying close attention, you might assume that it was just an Ethernet NIC. That's because it's a standard PCI expansion card. In terms of the fiber channel SAN, an HBA can be either an initiator or a target, or either in initiator mode or target mode. Hosts and servers almost always operate in initiator mode, and storage arrays almost always operate in target mode. Initiators send commands like read this and read that to targets, and the targets respond, and all over the fiber channel SAN, of course. Now, HBAs tend to be expensive, and one of the reasons is they contain local processing power to offload all fiber channel related processing. Basically, host resources like CPU and memory are not lumped with the burden of processing fiber channel protocol related tasks such as framing and flow control. And this actually goes a long way to making fiber channel SANs high performance. At a cost, of course. Oh, and fiber channel HBA cards usually come with a boot BIOS. This boot BIOS allows you to select a remote SAN-based volume as the boot volume for your server, allowing you to deploy diskless servers that boot from SAN. Okay, each HBA card has either one or two SFP modules in it. The HBA in our picture has one that we've just highlighted. Now, SFP is an acronym for Small Form Factor Pluggable. It's sometimes referred to as a GBIC, or more commonly a transceiver. This is the module that our network cables plug into, and as we've hinted earlier, these can accept either copper or fiber cables. In the image on the screen, the one on the left is an electrical SFP and it takes copper cables, with the one on the right being an optical SFP, accepting fiber optic cables. Again, optical is pretty much the de facto standard deployed in the real world. And on the topic of optical SFPs, these come in two flavors, shortwave and longwave, referring to the type of laser or LED that they use. Within the confines of the data center, shortwave is definitely the king. The SFPs are cheaper and they operate over cheaper fiber cables, and the distances that shortwave lasers operate over are extremely well suited to the kind of distances common in the data center. Longwave tends to be less popular in the data center and far more common for long distance links such as site-to-site remote data center links. Now then, worldwide names. Each and every HBA port in your data center will have its own worldwide node name and its own worldwide port name, either WWNN or WWPN. As far as storage administration goes, we almost always work with worldwide port names, WWPNs. In some respects, a worldwide port name is like a MAC address in the Ethernet world. It's usually burned into the physical HBA port. However, unlike MAC addresses, worldwide port names are not used in fiber channel frame routing and frame delivery. Instead, they're used for security purposes such as zoning, which we'll cover later in this lesson, and also LUN masking, which we cover in the lesson on storage arrays. The important point for now is that each port on your SAN, initiator and target, and also switch ports have their own worldwide port name, and you will use these on a regular basis. For the record, worldwide names are 64 bits in length, and they're usually expressed as 16 hexadecimal numbers, with the numbers divided into 8 pairs, each set of 2 separated by a colon as shown in the slide. Pretty ugly, right? But get comfortable with them, because you'll use them regularly in your day-to-day job as a storage admin. Finally, the Converged Network Adapter, or CNA for short. CNAs are really similar to HBAs. They're usually PCI expansion cards, they perform fiber channel protocol offloads, and they can have optical or electrical SFPs. The major difference is that CNA connects to a data center bridging or DCB Ethernet network, and we sometimes call DCB Ethernet CEE, or Converged Enhanced Ethernet. This means that they're based on 10 gig, 40 gig, or maybe 100 gig Ethernet technologies. The protocols they support and provide offload functions for include Ethernet, Fiber Channel over Ethernet, and iSCSI, making them quite a bit more flexible than fibre channel HBAs, which can only connect to fibre channel networks and only provide protocol offloads for the fibre channel protocol. But this flexibility of the CNA comes with a price tag. CNAs tend to be the most expensive option. Now then, let's take a look at the exciting world of cabling.